This is sample 7-3, up the hill again. It's on page 289 in your book. So in sample 7-3, we found the net work done on a crate that you were pushing up a hill. We found the work done by the applied force, the work done by gravity, and the work done by friction. And we found out that the net work done on the block was 57 joules. So we learned in our section on the work energy theorem that if you do work on an object, you can change its kinetic energy. We've done positive work on this crate, which means we've increased its kinetic energy. We're not increasing the mass, so we're clearly increasing the speed. So our question here is if the speed at the bottom of the ramp was 0.75 meters per second, what's the speed at the top of the ramp? Okay, so let's start with our work equals delta kinetic energy. Okay, so the net work done on the crate is final minus initial. Just to be explicit, 1/2 m VF squared minus 1/2 m VI squared. Okay, so I'm going to plug in some numbers here. 57 joules was the net work. I'm going to leave the 1/2 mvf squared, and I'm just going to solve for the initial kinetic energy. 1/2 times 23 kilograms for the mass of the block times 0.75 meters per second, quantity squared, gives me 6.5 joules. A little algebra gives me 63.5 joules equals 1/2 m VF squared. So multiplying by 2 and dividing by the mass gives us a final velocity of 2.3 meters per second. A couple ways you could have done that, but you get the same answer either way. So now we know how fast the crate is moving at the top of the ramp, and that should make sense because since we applied a net force, the crate should have accelerated, and in fact it did. So we'll do lots more with the work energy theorem in the days to come.